Lesson 3-2, Centripetal Force. According to Newton's second law, which was F equals ma, where there's acceleration, there's a force to cause it. So, if I have F equals ma, but our acceleration is centripetal acceleration, the centripetal force must be the mass times the centripetal acceleration. So centripetal force would be m times v squared over r, or m times r omega squared. Be careful though, centripetal force is not a new separate force created by nature. It is just the force required for circular motion. To go in a circle, it's the centripetal force is the force required. Some other force creates a centripetal force, such as if you're swinging something from a string. The tension in the string makes it go in the circle. Or a satellite in orbit. It's the gravity that makes it move in a circle around the Earth. Or a car going around a curve. It's the force of friction between the tires and the road that make the car go around the curve. You know, when it's icy and there's not as much friction, your car doesn't go around the curve very easily. Let's say a 1.25 kilogram toy airplane is attached to a string and swung in a circle with radius 0.5 meters. What's the centripetal force for a speed of 20 meters per second? Alright, so the idea is we've got this little person, he's got this airplane on the string and it's going in a circle. The radius is 0.50 meters, speed of 20 meters per second. Well, since I have speed or velocity, linear speed, I could say the centripetal force is mv squared over r. Plug in the numbers and run it through the calculator, and we should end up with 1,000 newtons. So it requires 1,000 newtons to keep this plane going in a circle. Now what provides that? Well, he's pulling on the string, so it would be the force in the string, otherwise known as tension, that provides the centripetal force. What affects centripetal force the more? A change in mass, a change in radius, or a change in speed? Well, let's see. Centripetal force is mv squared over r. So all three of them change the centripetal force, but notice it's the speed that's squared. So it's going to be a change in speed since it's squared and the others aren't. Any change there gets squared. So why do objects seem to fly away from circular motion? Well, let's think about it this way. So if something's moving in a circle, its centripetal force is pointing towards the center, and its speed is going that way. So if the force disappeared, it would just travel in a straight line and wouldn't change. It doesn't go straight out from the circle, it flies out tangent to the circle. So they really go in a straight line tangent to the circle according to Newton's first law, which is an object in motion stays in motion at a constant velocity in a straight line unless acted upon by a net force. So if there's no net force, it's going in a straight line. How does the spin cycle in a washing machine work? Well, in your washing machine tub, it spins around, right? And your clothes get wadded up against the side. So we have our centripetal force being provided by the normal force. And that makes the clothes go in a circle. But there's holes in the sides there, so water can go through the holes. So the water is going to go in a straight line tangent to the circle. So it's not so much that the water is spun out. The water just continues in a straight line. What happens is that the clothes are moved away from the water. Remember the good old days? No, it's way before your time. But in the good old days, when cars were big and the seats were vinyl bench seats that went all the way across, and there were no seat belts? Well, when a guy would take a girl out on a date and he wanted to get cozy, he put his arm on the back of the seat and make a right-hand turn. All right, so here's the guy with the steering wheel. His arms on the steering wheel, actually puts one arm there onto the back of the seat. The girl's over here, sitting there. And what he would do is he'd take a right-hand turn, kind of a sharp one. And the guy would turn, since the tires and the steering wheel provide the centripetal force through friction. But it's a vinyl bench sheet, it's slippery. And so the friction between the seat and the girl was not enough. So the girl would continue on a straight path. Oh, and look at that. They meet right there. The girl would continue a straight path while the car turned underneath of her, and she'd end up in the guy's arm.